Hello, bachas. Welcome back to the channel, the F in Physics, where the F in Physics stands for fun. So, in the previous class, we saw the formula for gravitational force, that was Gmm over r square, where r is the separation between two point masses, capital M and small m. G was a constant. We also spoke about a formula for gravitational field strength. It was Gm over r square, where m is the mass of any object whose field strength you are determining, and r is the radius of the object. In today's lecture, we are going to talk about gravitational potential energy. Now, if you recall the formula that you have learnt in your school, or had learnt rather, when you were in 10th grade or lower grades, was GPE is the product of m into g into h, where m was the mass of any object which you raised it to a height h, and g was the gravitational field strength. This value of g back then you considered to be 10 meter per second square or Newton per kg, and it was taken or treated as a constant. The only reason, bachas, it was treated as a constant is because the height to which you raised an object was very small compared to the radius of the earth. Radius of the earth is around 6,400 kilometer, and this h that was given to you was 5 meter, 10 meter and so on. Very small compared to the radius. But now at this level, because we are talking about celestial objects, the height that you will consider is going to be more than 6,400 kilometers, or the r that you consider is going to be more than 6,400 kilometers, which means this formula is not going to work out. So we have to derive a new formula which does not has this small g. Okay, and the formula is, you just take this m and h. Okay, h is basically the separation, I can call it as r. Instead of g, I can use this formula, right? Capital G, capital M over r square. So if this is earth, this is me, mass small m, earth ka mass hai capital M. Our separation from the center, again the separation we take from the center, is r. Okay, then GPE will be my mass, because I am gaining the energy, the distance to which I am being lifted, into g, where g is the gravitational field strength at this distance. So my GPE becomes, I just reshuffle this, over r square into r. So the value of GPE is Gm small m over r. Now according to this formula, bachas, GPE is inversely proportional to r, which means if your r is increasing, your GPE is decreasing. But this is not what you have learned, and this is not what GPE actually means. According to GPE, if my separation increases, my GPE needs to increase. So we go back to the same formula, GPE is equal to, and I just put a negative sign. Why do we put a negative sign? We'll see this in the next video. Now if I relate my GPE, see, my g is a constant, mass of the earth is a constant, mass of any other object that you are raising will be a constant. So GPE becomes inversely proportional to 1 over r with a negative sign, which means if your r is increasing, 1 over r will decrease, but minus 1 over r is going to increase. Therefore your GPE is going to increase. I hope this short video on GPE was clear to you all. I'll speak about this in the terms of work and force in the next video. Until then, take care, bachas. Thank you.